Most of us have to connect to public Wi-Fi at some point in our daily lives, maybe at Starbucks, an airport, or a hotel. It is convenient, but it's definitely not secure. So to fix that, I built this personal travel router with Raspberry Pi and a USB Wi-Fi adapter. And I also powered it with a mobile battery, which keeps running for hours and stays incredibly stable. I will link all the links to all the parts I'm using down below. In today's video, I'm going to walk you through exactly how I built this little gadget, a custom travel router that keeps your connection private and secure no matter where you are. To build this router, we need a Raspberry Pi 5, a microSD card for the operating system, and a card reader to flash the OS onto the card from our laptop. I also need a USB Wi-Fi adapter, which we'll configure as an access point. And finally, we need an Ethernet cable because we need to connect to the Pi through the wired connection to set it up on the first boot. In this project, we are using OpenWRT as the operating system. We navigate to the installation section and click the factory image link to download the image for our Raspberry Pi 5. And once the download is complete, we insert microSD card into our laptop. Open the image flashing tool like Blender Etcher, then select the image file we just downloaded, and choose our microSD card as the target device and go flash. The process won't take too long because OpenWRT is really a lightweight system. Now we insert the flashed microSD card into the Raspberry Pi 5, and then connect the Pi with our laptop using Ethernet cable. And finally, we power it on with a USB Type-C cable. With everything connected, we move on to the next step. Now open the terminal and type SSH root at 192.168.1.1 to connect to the router. And firstly, we set up a new password. And here you can try to set up the password as secure and strong as possible as you can. Once that is done, we use cd command to navigate to our configuration directory. We also can take a look at the network file with vi command. And here you can see our IP address is still using the default one, and it's a great idea to change this to a new one for better security. To do this, in the terminal we type UCI set network.lane.ipaddress equal, and here I'm using 10.123.1.1 as our new IP address. And also type UCI commit to save the change we made. We also need a new wireless interface to broadcast over network, so we set network WWAN equal interface. And also set this WWAN's protocol to DHCP for assigning IP address dynamically, and also set the DNS to Cloudflare and Google for a better resolution. And finally, we also type UCI commit to save all the changes we made, and reboot to restart the Pi to apply all the configuration. So once the Pi finished rebooting, we can use SSH root at 192.168.1.1 to SSH back to our router. But it doesn't work, which means our custom IP address is working as intended. So we try with our new IP address. And type yes to confirm and enter the password, and then we'll finally be back inside the OpenWRT again. And also to double check, we can use the command ifconfig. And then you can see the interface using the new IP address and everything is working perfectly. But if we give a quick ping test to youtube.com here, and you will notice that there's no response. This means our router is not connected to the internet yet. So to fix this problem, we directly connect it to the configuration page through the IP address and enter the password we previously used in terminal. And here we go directly to the network tab and click wireless, and then go click this scan button to search the available Wi-Fi networks around us. And here in my case, I'm going to use this Buffalo one and click join network. And don't forget to click the Replace Wireless Configuration option, and then enter your Wi-Fi password. And once finished, we click the Submit button. And also just leave all the settings as default. But at this point, our configuration has not applied yet. And if we click this and save changes here, and we'll see all the operations we've done are actually the UCI commands. And click Save and Apply here. And then after a few seconds, our configuration will be applied. And next, we're gonna set up our firewall. We go straight to the firewall page and change the input option of our WAN interface to accept, and then save and apply. So now our router should be connected to the internet. And to confirm this, we can just rerun our ping test to the youtube.com. And as you can see, the responses just come up instantly right after we hit enter. So now we are ready to install packages for configuring our router. But before that, firstly, we use OPKG update to update our packages to the latest version. The first command we need to use is list USB. But since it's not installed by default, we use OPKG install USB utils. And this command is going to install several USB related tools we need in the following steps. And now we retype list USB. You're going to see there's 4 bus devices. And then we insert our USB Wi-Fi adapter and retype list USB. You're going to see one of them changed to, well, in my case, it's Realtek disk, meaning our Raspberry Pi has detected that our USB Wi-Fi adapter. And to make our Raspberry Pi recognize the USB from disk mode to Wi-Fi adapter mode, we use another package called USB MOS switch. And once the package is installed, you're going to see our USB device will change from disk to a network interface controller mode, which means our adapter is working properly. And finally, we also need a driver for our Wi-Fi adapter. And after I've tested a lot of different commands, I finally found one that worked perfectly. Was this command. Well, this might vary depending on the model of your Wi-Fi adapter, but for the adapter I used in this tutorial, it works pretty well. Then after finished installation, we use another command, mode probe, and with the name of the driver we're gonna use, and then execute. Type iwdev to check interface, and you can see we still have only one interface listed at this point. But no worries, we are gonna go fix it. So firstly, we navigate to the config directory and use VI command to edit our wireless configuration file. So here we jump into the Radio 1 interface and flip the option disabled from 1 to 0, and then enter :W to write the file and :Q to quit the file. And the second thing we need to do is to execute the Wi-Fi command, which helps reload the wireless configuration we just made. And also if we run iwdev this time, we're gonna see there's 2 interfaces, and the new one is the physical one, which is act as an access point and exactly the USB Wi-Fi adapter we are using. And also to make our setup a bit more polished and make our router easier to recognize, we can jump back to the wireless configuration file we just edited and change the option SSID from the default OpenWRT to a customized one. And in my case, I'm using a Raspberry Pi router as the new SSID. And don't forget to give your router a password by adding option key. And here for simplicity, I just give a simple password, which is router123. And the same way, :w write in and :kill to quit. Cool. And the next thing we need to do is to make this Wi-Fi command executed automatically every time the router is powered on. So to do this, we navigate to a directory called init.d. And here we use vi with the file name. Here I'm using Wi-Fi adapter to add this new script. So inside this file, we add a short snip of code here. What is happening here is the start equal 99 gives a higher start priority, which means it runs after most services have initialized. And also the stop equal 10 gives a lower stop priority, which means it shuts down before most other services. And also the start function introduces 5 seconds delay to make sure the system is stable enough before we run the Wi-Fi command. And as always, :w write in and :kill to quit. And last but not least, use chmod +x command to give permission to this script file. And also use the enable command to make this file executable. And finally, we are all set. Go ahead and use the reboot command to reboot our router and test it out. So after a few seconds, you should see the customized SSID we just made. Here, in my case, is Raspberry Pi router, and I can also connect it with the password we just said. So it's just authenticates like a standard Wi-Fi access point. And how cool is that? And to verify the network is working, we can just randomly go to any website like YouTube, and you can see that everything just works smoothly. And now the only one task remains is setting up the OpenVPN server on AWS. And here I've prepared a fresh AWS account for this demo. And since using the root user is not considered a good practice for managing the AWS resources, so we're going to create a new IAM user for our specific use. And then go directly to click the Create User button. And here I'm given a name called Router Manager. And click the box to provide the access for this user to access the AWS console. And here we choose not to create a new password. And then go Next. And here for simplicity, we just give this user an administrator access policy. And then go Next. And finally, quick review the details and create the user. And once the user created, we click the download CSV files to save all these sign-in details. And then jump back to the user list. And you can see the user has created successfully. And now we are ready to log out the root account and sign back into the console with the IAM user we just created. So now we've signed back into the AWS console. And in my case, the user is operating in Sydney region, but you can use whatever region you like. And here we head over to the EC2 dashboard and click Instances. And then click the Launch Instances button. And since we're using the pre-built OpenVPN server here, so we just go browse more AMIs here, and then type OpenVPN in the search bar. And here we're gonna see several options available here, but we're going to use this first one, which stands for the Bring Your Own Lessons version. Click Select and quickly check the overview and click Subscribe Now. So now our OpenVPN image has loaded. As for the instance type here, we just choose the t2.micro here, and because it's really enough for this lightweight VPN server. And also click Create New Key Pair to generate a key pair for our instance. So here I give it a name called Broader OpenVPN key. Yeah, just give a memorable name. And click Create Key Pair and save. And also for the security group, we better change this anywhere option to restrict the access to our current IP address. So we change all these anywhere to my IP option. And once everything looks good, we click Launch Instance button. So now AWS is initializing our instance. It probably shows pending at first, but just give it a few seconds and the state is gonna switch to running. So once the instance is running, we click that instance and go to the Connect panel. And also click the SSH Client tab. And then we're gonna see there are several instructions for us to connect to the OpenVPN server using SSH connection. So here we open up a new terminal window and follow these instructions and prepare for the SSH connection. And there is an important note here, which is we should not use the root user as the username to SSH connect to the server. We should use the username OpenVPN AS to access our OpenVPN server at this very beginning. And once the command executed, you will see several prompts and agreements during this first initialization. And for simplicity here, we just simply type yes and press enter for all the configuration options. And eventually the setup script will ask you to create a password. So enter your desired password and leave the activation key as blank. So once the initialization finished, we access the OpenVPN login page through this admin UI link. And here we use the username OpenVPN and the password we just created. And click sign in and accept the agreement. And now we are inside the OpenVPN access server dashboard. And the first thing we need to do here is to configure the routing behavior. So we click the VPN settings and scroll down to the routing section. And here you will see an option called Should Client Internet Traffic Be Routed Through the VPN? And it's exactly what we want. So we toggle it to yes. And then scroll down to the bottom and click Save Settings. And also after saving, we click Update Running Server to apply all changes. So at this point, our OpenVPN server is fully configured and ready to use. But before we integrate it with our router, let's confirm our current IP address. And in my case, I'm located in Japan, so the IP shows a Tokyo-based address here. And now let's finally integrate OpenVPN to mask our real location. So first thing we need to do is to SSH back to our Raspberry Pi router. And as always, we use OPKG update to refresh all the packages first, and then follow the documentation and install the tools for OpenVPN using this command. And also don't forget to install the second tool as the extension for us to integrate with OpenVPN inside the OpenWRT web interface. And once the installation completed, we reboot our router. And from now, our OpenWRT GUI will have a brand new OpenVPN page available for setup. So now our router reboot finished. So we log back into our OpenWRT web interface. And you will see there's a new page called OpenVPN, which means our installation was successful. And next, we switch over to the OpenVPN server web interface and access the admin panel. Because here we want to generate a specific profile for our Raspberry Pi router. So here we go straight to the user management and click user profiles. And also click plus new profile. And also leave a recognizable comment for this profile and click create. And also save it on our laptop. And now if you expand this OpenVPN, you're going to see there's a new entry we just created, and with the comment we added in the profile. So now we upload the configuration file to the OpenWRT, the .ovpn file we just downloaded, and give it a simple name. Here I'm using Router Manager, and click upload. And then you will see there's a new instances here for our OpenVPN called Router Manager. And to make this connection work, we need to provide the authentication credentials using this .auth file. In the edit page of our Router Manager instance, we find a line of code called auth user pass. And also leave this default path of our auth credentials file after this command. And finally, in the second text box, we leave the first line with the OpenVPN username and the second line with the password of this username. Now, if everything's set up correctly, you should be able to switch the status of our Router Manager instance from stop to start. And to confirm our VPN is actually masking our location, and go to any IP address check website. Instead of my real location in Tokyo, it's now pointing to the AWS instance hosted in Sydney. And even those previous advertisements now change from Japanese to English, which is another sign that our traffic is being fully routed through the VPN tunnel. So just like that, our real location is now completely hidden, and our connection is now private and secure. Alright guys, this is full walkthrough of how to build our custom travel router. And I hope this video helps you stay more secure on public Wi-Fi and also gives you the confidence to build one of these by yourself. If you have any questions, feel free to leave a comment, and I'll see you in the next one.